What do a thunderstorm cloud and a pot of boiling water have in common? Both are demonstrations of convection in action. In this video, we will talk about convection and its role for heat transfer in the troposphere. Convection is the primary mechanism of heat transfer in fluids. Since both the atmosphere and water are considered fluids, heat transfer in this medium mainly occurs through convection. In convection, the fluid is warm from below. Certain areas of the fluid are heated more than others, causing those portions to rise as they become less dense. This rising motion is visible in boiling water, where bubbles form and rise from the bottom of the pot at the same spot. While some parts of the fluid rise, others sink to replace them, creating a continuous cycle of motion. In this video, we can observe the rising air bubbles in boiling water, illustrating this principle. Similarly, in the atmosphere, there are rising warm air currents and sinking cold air currents. The Earth's surface acts as a heating plate for our atmosphere. The surface absorbs solar radiation unevenly due to variations in terrain and surface properties. For instance, water surfaces and land surfaces absorb heat differently. Even among land surfaces, the absorption varies based on properties like color and texture. A dry plowed field, for example, absorbs more radiation due to its dark color compared to a green field which reflects more sunlight. These differences in absorption, known as albedo variations, lead to uneven heating of the Earth's surface. In this image, we can see a small pond surrounded by a wooded area. The pond absorbs more heat and warms up faster than the surrounding woods. This creates localized differences in heating, which in turn drive convection within the atmosphere. Now let's take a look at this diagram of how convection takes place. Here we have two surfaces, grass and plowed field. The plowed field, being darker in color, absorbs more sunlight and warms up more than the surrounding grass. As a result, the air above the plowed field heats up more than the air above the grass field. Warmer air is less dense than the surrounding cooler air, and due to buoyancy, it rises, forming a bubble of warmer air called a thermal. This bubble of warmer air rises aloft and cools on its way up. If the air cools enough for water vapor to condense, clouds will form. Meanwhile, cooler air from above sinks to replace the rising air. This creates a closed circulation known as a convection cell. Between the cell, warm air rises at the center, while cooler air sinks around the edges. This process continues throughout the day and can produce clouds if there is sufficient moisture in the air. Convective cells are distributed across the entire Earth's surface and can vary in scale. They may be as small as a few thousand feet, extended to the top of the troposphere in the form of towering thunderstorm clouds, or even drive large-scale atmospheric motions. For example, the Hadley cell in tropical regions is a planetary-scale convective system that transports heat from the equator towards the pole. Convection is the primary mechanism of heat transfer in the troposphere, playing a crucial role in regulating temperature, driving atmospheric processes, and governing the movement of heat, moisture, and energy which directly impact weather and climate.